Hello, this is Charlene. We are going to be talking about some conditional arguments. Well, and actually some other kind of arguments as well, but we're going to focus initially on conditional arguments. We've got some basic information here. The conclusion of a deductive argument is true whenever the premises are assumed to be true. For example, we have two premises here. We have all politicians are married. We also have Senator Harris is a politician. And because we assume these premises to be true, we can make a compelling case that the conclusion is also true. And our conclusion says that Senator Harris is married. So if all politicians are married and Senator Harris is a politician, then we can make the valid argument that Senator Harris is also married. Some basic information that we need to kind of keep in our head is that a truth table also can prove that a statement is valid. If the final column of a truth table is all true, then it is valid, and we call this a tautology. Here is kind of a example of a truth table where you can see that the final column here is all true, 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 and that is what we call a tautology. And that would mean that this statement right here is valid. Another way to think about this or state this is that the argument is sound if it is valid and its premises are all true. Of course, the opposite of this is if an argument is not valid, which is also the same thing as saying it's invalid, we call this a fallacy. So it's either valid or it is a fallacy. Okay. Now we need to look at this chart of conditional statements. It's a truth value chart because we want to be able to recognize a couple of uh, patterns that emerge with the relationships between the statements. Let's see, just a little bit. There we go. Okay. So here we have the conditional statement, the converse statement, the inverse statement, and the contrapositive statement. You may or may not be uh, very familiar with those, but if you are, you should hopefully know that the conditional statement, the first statement, is equivalent to the final contrapositive statement. So these two statements are equivalent. We know that because it's true, false, true, true. And it's exactly the same truth values. True, false, true, true. That makes them equivalent. Well, when they are equivalent, that also leads to a valid argument. So the conditional statement is not equivalent to the converse. It is not equivalent to the inverse, and those will always lead to an invalid argument if you have that relationship. So, just wanted you to see that because we're going to match that to a pattern in the next chart that we're going to look at. So down here, we have a chart that says basic conditional arguments. And of course, direct reasoning. This is the one that actually you would recognize as being the conditional statement. This would be the original conditional statement. Original conditional statement. Conditional. Okay. So, and you can see it right here because it says that if P, then Q. And then the second line also is basically saying P, therefore Q. And that is the relationship. It's like if P is true, then we can assume that Q also is true. If P, the condition of P is met, then Q will also be the result or the conclusion. So that is the original conditional. Now, if you'll notice, we have converse here in the second column. We have inverse in the third column, but notice they are listed as invalid. That's because the conditional statement, the original conditional statement, is never equivalent to these two. The only thing that the conditional statement is equivalent to is the contrapositive. The contrapositive is on the end, and as you can see, that's valid. So there's a pattern there. Like I said, let's go back up here and see if we can kind of look at it again and see this. It's like the conditional statement is equivalent to the contrapositive statement, and that leads to a valid argument. Down here, I have this is the conditional statement right here in this column, and this is the contrapositive statement, and it leads to a valid argument. So, and everything else in the middle, these two are not equivalent, and so they are not valid. So there's a little bit of a pattern there. However, we're just going to learn how to convert our English sentences to these symbolic sentences. If P, then Q. This one says, if Q, then P. And this one says, if not P, then not Q. And this one says, if not Q, then not P. So we're going to learn how to convert our English sentences to this symbolic language, and we'll be able to use this chart or one similar to it to identify if our arguments are valid or invalid. So my favorite version of this chart is this one. This one is kind of listed, and it does kind of succinctly list the fact that it's conditional, converse, inverse, and contrapositive. But for the purposes of all of our problems, I actually like this chart a little bit better. Here is our direct reasoning. That is the original conditional statement. And then we have our contrapositive here. Then down here, we have our converse. And right here, we have our inverse. But I like the way this chart is organized because it lists all the valid arguments up top. You can have a valid argument based on direct reasoning. You can have a valid argument based on contrapositive. You can have a valid argument based on a disjunctive reasoning, which disjunctive has to do with the word or and the symbol or. And then you can have a valid argument based on transitive reasoning. And then also on the second row, invalid arguments. So all of the invalid arguments are listed on the second row. And of course, here we have it's invalid by converse by reason of the fallacy of the converse. It is invalid argument by reason of the fallacy of the inverse. And then there's misuse of the disjunctive reasoning and misuse of the transitive reasoning. So, but that's the thing is that all of these are valid on top and all of these are invalid on the bottom. And again, the relationship is that the original conditional statement will always be equivalent to the contrapositive, and that leads to a valid argument. But the the original contrapositive is not equivalent to the converse, and it's not equivalent to the inverse, and therefore that always leads to an invalid argument. Okay, so but we're going to use this chart repeatedly while we're assessing some English word statements that we are going to convert into symbolic language. Our instructions tell us that we're going to translate each argument into symbolic form, and then we're going to determine whether the argument is valid or invalid. So let's look at what they've given us. They've said, if I study, then I pass. There's kind of an implied word then over here. Let's kind of put that in. It's kind of right there. And so we definitely have an if-then symbol. The if-then symbol, of course, is the right-sided arrow. So if I study, then I pass. So we'll call study the P thing, the first thing. If I study, that's the first thing, then I will pass. That's the Q thing. So we can translate it to P, if P, then Q. And then the second line says, I do not study. Okay, so study again goes with the P thing. So that means the second line is going to be not P. because P represents the word study. Okay, and then we've got therefore, I do not pass. So pass has to do with the Q thing. So this is going to be not Q. So I've got if P, then Q, then not P on the second line, and the final line is going to be not Q. So we can kind of wrap that up and express it like this. So it's if P, then Q, then not P, therefore not Q. So we're going to use that translation to symbolic language and compare it to our chart. Let's move that up so we can see it better. Okay, so where do we see this? I tend to like to look at the bottom line first. I've got a not Q here. So I want to look for not Q. There's Q, there's not P, there's Q, and then, oh, here we go, not Q, or it's not Q. Okay, and then if I go up to the second line, that's not P, and of course my original statement is right there. So this definitely matches with the fallacy of the inverse, which means that it is an invalid argument. So we have converted our um, sentence to symbolic language, and now we can determine that these three sentences, if I study, I pass. If I do not study, therefore I do not pass, is not a valid argument. So it is not valid by reason of the fallacy of the inverse. Our next set of statements says, if I am at the beach, then I swim. So we definitely have an if then statement. So we need our right-sided arrow. And we are at the beach. That's going to be our P thing. And then we are also swimming in the ocean. And that is going to be our Q thing. So we've got if P, then Q. If I'm at the beach, then I swim at the ocean. Then we also have in the second line, if I swim in the ocean, okay, that matches with the Q thing. So we're going to call that Q. If I swim in the ocean, it's still an affirmative. It's not negated. It's just if Q. Then I feel refreshed. I have a whole new statement. So we're going to introduce a new variable. So if Q, then R. So we are going to have R in our statement, a third variable. And then the last statement says, if I'm at the beach, and again, the beach has to do with the P, so we're going to call that P. So if P, then I feel refreshed, and refreshed went with the variable R, so R. And we can summarize all of that conversion from the English sentence to the symbolic sentence in this way. If P, then Q, and if Q, then R, therefore P, if P, then R. So that's what it's going to look like. We're going to look at our chart here and see if we can match this up. So again, I like to start at the bottom. We've got a P, if P, then R. So I'm going to look for, oh, there's if P, then R. Anything else? Nope, that's the only one that matches. So if P, then R. And then we go back up. If Q, then R, Q, then R, and our original if P, then Q. So that is where it matches. And so this is going to be the transitive reasoning. And this falls under the valid arguments section. So our original statements are going to be valid by reason of transitive reasoning. Okay? Our next set of statements says, if I am tired or hungry, I cannot concentrate. So again, there is an implied then right there. So if then, so it's definitely a conditional statement. If then. So for simplicity purposes, we are going to actually ignore the fact that it says or. We're just going to count tired or hungry as a single thing. So if I am tired or hungry, that's the first thing, then I cannot concentrate. So we do have the word not concentrate, but I'm still going to just call it Q. It's like tired or hungry is the first thing. If I am the first thing, then I am the second thing, which is not, I cannot concentrate. So the second line says, I can concentrate. So since can is the opposite of cannot, I'm actually going to negate the Q. I'm going to say not Q. So does that make sense? Like the Q appear says cannot concentrate. So the opposite of cannot concentrate is can concentrate. So I negate the Q on the second line. So the third line says that I am neither tired nor hungry. So that means that we are going to negate the word neither means the opposite if I am tired or hungry. Neither tired or hungry is not tired or hungry. So it's going to be not P. And now we can summarize this conversion in this way. And this is what we're going to look on our chart for. So again, I like to start at the bottom. This says if P, then Q, then if not Q, therefore not P. So I'm going to look for the not P on our chart. There's not P and there's not Q. That matches not Q. And my original, if P, then Q, if P, then Q. So that means that my statements are a valid argument by reason of the contrapositive reasoning, because that is a valid argument. So hopefully that helps you understand how to go through some of this process and how to use this chart, how to convert everything to symbolic language, and to verify if your arguments are valid or invalid.